Hello, my name is T. Bowler, and in this video we're going to be configuring Enhanced Interior Gateway Routing Protocol, otherwise known as EIGRP. This is EIGRP Lab 1. What I'm going to be showing you here in this lab is the EIGRP Basics. We're going to look at the EIGRP metrics. We're going to look at EIGRP K values. We are also going to be looking at EIGRP authentication as well. So what we have for you is all the routers are already configured and running. So now we need to do the IP addressing. On router 1 we have two loopbacks, both on the 172.16 network, 1 and 11. We also have two loopbacks on the router 4. We have two networks on router 4, loopback 0 and 1, the 10 networks, the 4 and 44. Then we have the connections in between, which are router 1 to 2 is 12, router 1 to 3 is 13, and so forth. So before we get started and take a look at EIGRP, we're going to go ahead and configure all the links between. Okay, so I have all the IP addressing done between the routers. We'll go ahead and do the loopback interfaces now. We have all the connections between the routers configured now. So what we'll do is we will go under the R1 loopback 0, give it the IP address of 172.16.1.1, and then we're going to go under loopback 1 and give it the IP address of 172.16.11.1. with the /24 subnet mask. We're going to go to router 4. It has two loopbacks as well. So we'll get into router 4. We'll go under interface loopback 0. We will give it the IP address of 10.4.4.4 with the /24 subnet mask. And then we're going to configure loopback 1 with the IP address of 10.44.44.4 with a /24 subnet mask as well. So the next command we're going to do is show IP interface brief. If I try to ping out now, 192.168.24.2, which is fast Ethernet 00. That's a connection to router 2. If we try to ping router 3, which is 34.3, we have connectivity as well. So now we're going to go to router 1. We'll do a show IP interface brief. We're going to verify connectivity to our directly connected routers, which is router 2, which is the 12.2. And then we will also verify connectivity to router 3, which is 13.3. Okay, so now we have full connectivity throughout our network. We're going to go ahead and start configuring EIGRP. And we will show you the basics of EIGRP in this lab. First, we're going to go under global configuration mode, and then we are going to do the command router space EIGRP, and under here is where we specify the autonomous system number. We're going to make the AS number the same for all the routers. We'll just make it 1. And as you can see, if we do a question mark under EIGRP router configuration mode, we have a lot of different options. What we're going to do first is advertise some of our connected networks into our router within EIGRP. We're going to do this with the network command. Just like some of the other dynamic routing protocols like RIP or RIP or OSPF as well. the simplest way to advertise networks in. Say you get a question on an exam and they want to configure all of your directly connected interfaces on your router into the EIGRP autonomous system. The easiest way to do this is with the network 0.0.0 network 0.0.0.0 command, and that should do it. So if I go to router 1 and do a show IP protocols, what we can see that we have right off the bat, what we forgot to do is we forgot to set auto summarization. So you can see these networks are being summarized at their classful network boundary. So we can see that EIGRP, without putting the no auto summary command, will summarize these networks by default. So let's go back and turn off auto summarization, because we do not want summarization performed at the classful network boundary. So we're going to go under router EIGRP 1, we'll do the no auto summary command, and that will disable automatic address summarization. Now that we have done that, if we do a show IP protocols to take a look at our EIGRP autonomous system 1, now we can see automatic network summarization is not in effect. And you can see that we have the routing for networks of 0.0.0.0. What this means that any connected network or connected interface on our router is going to be advertised into this EIGRP autonomous system. So it will process EIGRP updates and send updates out the interface. We can see this if we do a debug EIGRP packets command. What we can see already is we can see hello packets going out all these different interfaces, the loopback interfaces, the fast Ethernet interfaces. So just wanted to show you that, just to let you know that with that network command of 0.0.0.0, EIGRP is now being configured on all the interfaces. That's the easiest way to configure EIGRP, but can also be one of the worst ways to configure it. As we can see on router 4, we have two loopbacks, loopback 0 and 1. We'll go to router 4 and do a router EIGRP 1. We'll do our first command will be no auto summary, and then now we're going to add our network statements, and we're going to add them by the /24s in which they are part of. We'll do this with the 192, 168, 23, I'm sorry, not 23, 192.168.34.4. We will have an all match in this case. In this case, it's only going to try to establish an adjacency on the router where I have this IP address specified. Which is the serial 10 interface on router 4. Now if I do a do debug IP EIGRP packet, oh, it looks like I put the IP on there. There's no IP on there, so we'll do a do debug EIGRP packet. So now what we can see is hellos going out serial 10, and no other interfaces. This is because of our network command that we put in earlier for the 34.4. So we'll go ahead and turn off debugging, and we'll do our other networks, which are, we'll do 192.168.24.4. Again, we'll do the best way to summarize this. We'll do an exact host match. So the only interface with that IP address is where the EIGRP hello packets will be sent out. 24 is going out fast Ethernet 00. So now we're going to do our loopbacks into the EIGRP autonomous system. We're going to do that with the network statement again, with the 10.4.4.4. And for these networks, we're going to advertise the whole /24, which is 255.255.255.0. So we'll do this again for the 44 network. Again, /24 of the subnet mask of a /24. Now if I do a show IP protocols, you can see that I have these two /24s that I created and the two /32s, in which I'm just trying to establish an EIGRP neighbor relationship across. These other two networks are the networks that we're advertising into EIGRP, the /24s, where the /32s are the directly connected interfaces to our EIGRP neighbors. So now we're going to go to router 2. If we do the command do show IP interface brief on R2, we have two fast Ethernet interfaces. One of them is to router 1, which is in the 12 network, and one of them is to 4, which is in the 24, router 4, which is in the 24 network. We'll go under, do a router EIGRP and do a no auto summary. Then we will do the command network 192.168.12.2 with the 0.0.0.0. Then we will also do the 24.2 with the 0.0.0.0 as well. As you can see already, it looks like we have two EIGRP neighbor adjacencies that have come up already. We can check this information if we do a show IP EIGRP neighbors. It's going to give us our neighbor information, the IP address of the neighbor, and the interface in which it formed the adjacency over. It's going to give us the hold down time. It's going to give us the uptime, how long the neighbor relationship has been established. We have a couple other timers that we're not going to get into in this lab. They're more advanced timers that we're not going to worry about because this is a basic EIGRP lab showing you the basics of EIGRP. So let's go to router 3 and get it configured real fast. We'll do the command show IP interface brief. We will go now under router EIGRP autonomous system 1. We'll do the no auto summary command. Then we will do the network 192.168.13.3 all host mask, and then we'll do the network 192.168.34.3 with the all host mask. And as we can see, we have two neighbor adjacencies that have come up already. If I do a show IP EIGRP neighbors, we can see that we have now formed two neighbors with router 1 and router 4. Another helpful command we can do is show IP EIGRP interfaces, and then we can look at just one interface with this command. If we do the show IP protocols command, first off we have the administrative distance of internal EIGRP. The AD is 90, and for external routes we have the administrative distance of 170. Both of these can be changed under the EIGRP router configuration mode. So we can do this by going under router EIGRP 1, and we can do this by setting the, I believe it's the distance command, not under metric. I know for sure that it's not under there. If we do the question mark, we can see we can change those by doing the distance command. So let's not worry about that command right now. Again, the distance command under EIGRP will allow you to do that. The distance command will allow you to change the administrative distance of EIGRP. So by default it's internally is 90 and externally is 170. So what we're going to do next is on router 3, if we do a show IP protocols, the EIGRP metrics are these 5K values, which are K1, K2, K3, K4, and K5. This is the way that EIGRP finds the best path around the network, by using these 5K values. EIGRP is a Cisco proprietary protocol, which means it can be only run on Cisco routers, which kind of limits EIGRP in its scalability. Another thing with the EIGRP metric, it uses by default K1 and K3, which are bandwidth and delay. You can manipulate these metrics as well. And what we will do in a second is show you how EIGRP calculates the metric. If I go to router 1, I should be fully converged by now. EIGRP is on all, it has been configured on all the routers. If I do a show IP route EIGRP on router 1, this will show us just the EIGRP learned routes. We have the 24 network, we have the 34 network, and I have the 2 links off of router 4, the 2 loopbacks. And as you can see, the number is the metric, which is the feasible distance with EIGRP. If I do a show IP EIGRP topology to look at the topology table, what I have here is one successor route for these 2 loopback interfaces off of router 4. They are both off of 12.2, which is, if I do a show IP EIGRP topology specifically for the network, This gives us more information on this specific route. It gives us the hop count, it gives us the MTU size, the load, reliability. These are the other metrics, the other K values, K2, K4, and K5, that we normally don't see EIGRP running by default. Reliability, load, and MTU. EIGRP is also a hybrid protocol. It uses, as you can see, it keeps track of hop count and uses bandwidth and delay as well. So that's why they call it a hybrid protocol. It calculates its metric based on the K values. And what we can see from this, if I look at the routing table again, if we look at 10.4.4.0, the feasible distance is 158,720. My advertised distance is 156,160. Now this is the distance it takes from router 2's perspective. That's how router 2 sees that distance to this network. Now the feasible distance is the total distance from router 1 all the way back to the loopback. The advertised distance is from router 2's perspective back, and the distance between router 2 to router 1, that's added on, and that's how you get the feasible distance. To calculate the feasible distance, it's not too difficult. The way you find out the feasible distance, they're both the same for both loopbacks on router 4. What we do is take 10 million, we multiply that by the lowest bandwidth to the host network, that's how you get the bandwidth. Remember, we're using K1 and K3 values. So K1 value is bandwidth, so it's taking that into perspective, and then it's also taking the K3 value, which is delay. The way we calculate delay is the total delay across all links to the host network. And then you take this value, so you add up the delay across all links, then we divide that by 10. And then we get the formula of bandwidth plus delay, and we multiply that by 256, and this equals our composite metric. So what we'll do is we will show you this real fast. So if we look at the link 10.4.4.0, we're learning it from router 2, which is 12.2. So if we do if I do a show interface fast Ethernet 00, what we can see is the bandwidth, which is 100 meg on the fast Ethernet interface. So bandwidth is 100,000 kilobits. what we need to figure out is the lowest bandwidth across all the links. So we have 100,000 kilobits here on router to router 2. If I do a show IP route on 10.4.4.0, it's going to take us to router 2. So again, if I do a show IP route of 192.168.12.2, that's the fast Ethernet interface to router 2. So if we go to router 2 and try to continue the trace back to 10.4.4.0, we are learning it via fast Ethernet 01, which is our connection to router 4. If I do a show interface fast Ethernet 01, we can see that the bandwidth is again 100,000 kilobits, or 100 meg. So what we'll do now is we'll go back to router 4. Again, if we do a show IP route on 10.4.4.0, we'll see it directly connected via loopback 0. So if we do a show interface loopback 0, we have a bandwidth of 8 million kilobits. So we know EIGRP is not going to be using this metric because it's the largest. It's going to use 100,000 because this is a tie between router 1 and 2 and router 2 and 4. They're both using the same bandwidth. So what we'll do is we'll open up calculator. We'll do 10 million. We'll divide that by let's do 10 million and divide that by 100,000, and that gives us 100. So what we'll do now is we will go under our WordPad, and we know that the bandwidth equals 100, so now we have to get the delay. Again, for delay is total delay across all links to the host network. So now we have to calculate the delay based hop by hop. So if we go back to router 1, if we look and do on fast Ethernet 00 is connected to router 2 that's got a delay of 100. So we'll add 100. Then we'll keep adding up the delay. From router 1 to router 2 we got 100. So we'll go to router 2. We'll look at the next hop to get to the source network, which is from router 2 to router 4. We have another delay of 100. So we'll add that. And then we will add up also. We will add up the delay on router 4 it takes to get to the loopback interface. So we go to router 4. We see the loopback 0, which is the 10.4.4.4, which is the network in question, is the delay is 5,000. So we're going to add that as well. So delay is now going to equal 5,200 or 5,200. So now that we have bandwidth and delay, we can calculate our formula, which is bandwidth plus delay, which is 100 plus 5,200, and we're going to multiply that by 256, and that's going to give us our composite metric. So 100 plus 5,200 is 5,300. So now what we're going to do is we're going to take 5,300 and multiply that by 256. and what we can see is 1356800. So again, 1356800. If we go to router 1 and do a show IP route on the 10.4.4.0 network, we have a metric of 158720. If we do 5300, multiply that by 256, we get 135680. So sorry about that. Looks like what we forgot to do is we have the total delay, but we forgot to divide that by 10. So we just messed up there. We'll take 5200, divide that by 10, and we have 520 total delay. So our total delay is 520 instead of 5200. So sorry about the confusion there. If we try to calculate it now, we have 620, which is bandwidth plus delay, and we multiply that by 256, and as we can see, it's 158,720. So if we go back under the routing table, we see the feasible distance of 158,720 for the network in question. So that's how you calculate the feasible distance, our composite metric. Again, the first number is our administrative distance, which is internally EIGRP, so we know it's 90. And then this metric is the composite metric, or the feasible distance. We just went through the metric. What we forgot to do is we forgot to divide 5200 by 10. So bandwidth, by default, the composite metric is bandwidth, which is the K1 value, and the delay value, which is K3, which is bandwidth is 10 million multiplied by the lowest bandwidth to the host network. So hop by hop, we saw which link had the lowest. Then we multiplied 10 million by that. Then to get the delay, we added up the total delay across all links to the host network. And then we had to divide that by 10. And then you take those two numbers that you get, then you take bandwidth plus delay, and then you take the sum of that and multiply that by 256, and then you are left with your composite metric, or feasible distance. So we just explained the composite metric and how EIGRP gets this metric. The next thing we're going to do is EIGRP authentication. Actually, get me 1 second. We will end with this. We're going to do EIGRP authentication now. The way we configure authentication within EIGRP is very similar to the way it is configured in RIP version 2 or OSPF. We will configure MD5 authentication between router 1 and 2. what we will do is we will go into router 1 and configure it first. We will configure the keychain. We'll give it the name R1 to R2. We'll have one key. We'll name key 1, and then we're going to give it the key string, which is the password of Cisco with the capital C. So then we're going to go under the interface connected from router 1 to router 2, which is Fast Ethernet 00. We'll do the command IP authentication mode EIGRP. Then we put our autonomous system number, which is 1, and then we specify MD5. As we can see already, our neighbor relationship is down that fast. The next command we're going to use is IP authentication keychain. We're going to put in EIGRP autonomous system 1, and then we'll put in our name of the keychain, which is R1 to R2. So now if I do a show IP EIGRP interface, no, actually that's not it. Let's do the command give me 1 second. If I do a show IP protocols, actually the command I'm looking for is show IP EIGRP interfaces detail, and then the interface Fast Ethernet 00. This is where we're going to be able to see our hello interval. We're also going to be able to see our authentication mode and the keychain configured. So again, show IP EIGRP interfaces detail and then the interface name. Very good command to have when trying to troubleshoot EIGRP authentication. So now let's go to router 2 and get it configured. We'll do a show IP EIGRP neighbor. We only have a neighbor relationship with router 4 because the neighbor relationship to router 1 is not up right now, because router 1 is configured for authentication and router 2 is not. We'll do the keychain of R2 to R1. We'll do key 1 and we'll give it the key string of Cisco. We'll go under interface Fast Ethernet 00, which we can see is the FA0, which is the connection to router 1. We'll do the command IP authentication mode EIGRP, then autonomous system 1, and then MD5. Then we also do the command IP authentication keychain for EIGRP autonomous system 1, and then our keychain, which is R2 to R1. So once I hit enter here, we should see the EIGRP relationship come up pretty quick. And as we can see from the output, we do see the adjacency has come up to router 1. The neighbor adjacency is up for about 10 seconds already. And that's it. That's EIGRP MD5 authentication and how to set it up and verify configuration. We go under global config, create the keychain, then we go under the interface you want to apply the keychain, and then you put in the mode as MD5, and then you also have to put in the keychain as well. So 2 commands there under the interface. To check this, we do the command show IP EIGRP interface detail and then specify the interface, and there you can see the keychain used and the authentication mode and a hello interval. Okay, so that's a good stopping point for our first EIGRP lab. Just giving you a rundown on the basics of EIGRP, how to enable it on the router, how to advertise networks into EIGRP, how to calculate the composite metric within EIGRP, a detailed look at the K values, and also a look at EIGRP authentication, which is EIGRP MD5 authentication in this example. So there's a lot more to the protocol. Just wanted to give you the basics in the first lab here. So I want to thank you guys for watching this video, and I hope to see you in the next one. Thank you.